All right. So, formal hypothesis testing. Remember yesterday, I said that we were just giving you the alpha, and later you'd learn how to calculate all this stuff. We're there today. Now, the majority of what we're doing today, the majority of what we're doing today is just putting together everything we've done so far. A little bit of everything from A and B and C in the last section of C. So it's just culminating here. Okay, we're just putting it all together. So this first page is just a list of what we're doing. This is the template. This is the template of what will maybe, I don't know, maybe a quiz come up. So we're always going to do one. We're going to, step one, define the population, the sample proportion, p-hat, the sample size, and level significance. Okay? Now remember, it's a very key thing here. This is usually, usually 0.05 unless given. So if it tells us, alpha is 0.10, which, may happen today. Otherwise, unless it is stated, math, we always tell you never assume. This is the one time you get to. If you're not told the alpha, the significance level, just assume 0.05. Right? So something will be assumed, some will be given, some will be given something else. Now, next thing we do is we check conditions. There was a typo error here, so please change these to p-hats. So we'll check our conditions. These are those steps on the last quiz that were just like missed because it was on the template. It was on the just like the last one, step by step. These are the exact same steps, in fact. Check conditions. Was it random or not? We said given. A lot of people didn't do that. This one, check for large sizes. Not done a lot. All right? It's the same procedure. 3, we're going to write that null and alternative hypotheses. So we're going to write the ho and the ha. And it's always going to be p equals a number, and this is going to be p less than, greater than, or not equal to. Those are going to be the 3 choices every time. So the ho is p equals a number. The ha is p is less than, greater than, or not equal. Step 4. We're going to do some math. Not very complicated math. We're going to take the p-hat minus the p, because there are 2 numbers, and look, that looks really familiar. We're going to divide by the standard deviation, which we've done already, which is the square root of p times 1 minus p divided by n. It's the same thing. All right, number 5. Number 5, we're going to find the area. So we're going to go back, and we're going to find the area. Often it's going to be to the right. Not always. Sometimes it'll be to the left. But remember, if it's ever to the right, we always do 1 minus. Okay? But we're going to use the chart from our blue book, from our formula packet. Which you're going to need. Okay? Then we're going to make a decision. Whoa, that's cool. We're either going to reject the ho or fail to reject the ho. Now, if we reject the ho because p is less than the alpha, we have convincing evidence for the ha. And if we fail to reject, we don't have convincing evidence for the ha. So we either have convincing evidence or we don't have. Just like we talked about yesterday. We either find the person guilty or not guilty. We're not saying innocent. We're not saying the ha. We're just saying rejecting the ho or not rejecting the ho. We're not doing the ha. All right. Now, we're going to go back to the kissing example from yesterday. Actually, don't leave this here. Okay. So we're going back to the kissing example. Who kisses right? So we got to do, up to number one, we're going to do 1, 2, 3, 4 things. So first off, we're going to say P. Okay? If you remember from yesterday, that was the proportion of couples who kiss the right way. Remember, right is in quotation marks. Meaning that's not correct, it's with their heads tilting to the right. So when they kiss, they tilt their heads to the right. Now, our p hat, which is our sample proportion, p hat, is the number of people we had. I think it was 0.669, was it? Look back, write that down. So from yesterday, it was 83 out of 124. That was given to us in the story problem, which equals 0.669. There's my p hat. So I have p and p hat. Two things we need. We need our n. That's right in that fraction. There were 124 couples observed briefly. And then the alpha. Okay? So if it didn't give us the alpha, it's 0.05. It was given to us in that problem. But remember, just remind yourself, it's always going to be 0.05 if not given or if not stated. We always assume 0.05. So now we check conditions. There's 3 conditions we want to check. We write random, question mark, and the problem, if you remember yesterday, it said it was given, and we do a check mark. Was it random? Yeah. How do we know? They told us it was random. And then we check 2 things. We're going to do n times p, and we're going to do n times 1 minus p. Okay? So, n times p is 124 times 0.669, and 124 times 0.1 there, 0.331. Okay? And this equals 83, and this equals 41. Both are greater than or equal to 10. Check. You can do it in one motion. You don't have to do it for both. They're both greater than or equal to 10. Now, this often happened in Algebra 2. This question was asked, what if they weren't greater than or equal to 10? We never gave you that situation. I don't think we're going to give you that situation here. It doesn't mean you don't do the study. It's just kind of like a warning. Proceed with caution that it may or may not be the most valid. Oh, this was screwed up. So scratch that out and just write ho and ha. Is it right in yours? Yeah. Okay, it's messed up. It's messed up in mine. Right, we're writing the ho and the ha. Yeah, no an alternative, but in mine it's screwed up. So I thought you had it right. I couldn't remember. So ho, p equals, and ha, p we don't know yet. So if you remember, it said they assumed half the couples kissed right. So that's 0.5. And then they wanted to see if they thought it would be greater than 0.5. So that was our ha. that's all from yesterday. Now we're going to get into math. And this is very easy math. Z is equal to 0.669 minus 0.5 divided by big old square root 0.5 times 0.5 divided by 400. Now, you have two choices. I'll show you how to do it in the calculator. You can do it in 2 steps and get the bottom and the top separately. But if you use this calculator, you can also, this little trick here, so how you know it, if you hit alpha y, maybe, and d, you can set the fraction. And then you just type in 0.669 minus 0.5 in the top, and then go down and just do second square root. You don't have to, you can just do it separately, whatever works for you. And then 0.5 times 0.5 divided by 400. Whoops.
That was alpha y, right?
Yeah. That's screwed up. Something got messed up there. It should. I typed it in before like this. Oh, I did 400 instead of 124. That was silly of me. Sorry, my bad. I was thinking about a different problem. So let me try that again. Sorry. So alpha y, if it wants to work for me, alpha y. Enter. All right, I'm just going to go from the front. So 0.669 minus 0.5. Go down to the bottom. Second square root 0.5 times 0.5 divided by 124. That should make a difference. That's the difference right there. Okay, what we get is 3.7. Be careful rounding. The 3.78. Okay? 3.78. It's 77. What was it? 779? Oh, sorry. Oh, that's weird. No, it is, because when I did before, it ended up 3.78 on a different calculator, and some people got 3.76. Let's go with 3.76, that's what it's showing. I don't know. Maybe it rounded weird. Okay, so 3.76. It's going to be pretty much the same anyway. You see why in that. Now, all right, so find the area. So let's do a quick. One, two, three, right? And this isn't going to matter here in a while. So 3.76, just put a mark here, shade right. We said greater than, right? 3.76, and write that right there. Now, look at your chart, okay, in your blue formula book. That says you would need. Look at your blue chart and find 3.76. Yes, it is going to be on the positive side. That's a good observation. What's the problem? It only goes to 3.49. So go over just to the far right off the edge of the earth, find the last number on the far right. What is it?
0.999.
Yeah, it's so tiny, it's infinitesimal. So it's 0.998. But the problem is, 0.9998 is to the what? Left. We don't want to the left. So remember, we always do 1 minus, which gives us 0.0002. And then we get to the last part. We compare 0.0002 and 0.05. Our p hat, our p, and our alpha. Is our p less than or greater than? Less than. So we're going to reject the hoe. Now here's where the whining pine comes in. We have a paragraph to write. So, right here. Since my p-value is less than, alpha, we reject the hoe, or the null hypothesis, and have convincing evidence for the proportion of couples who kiss the right way is greater than 50%. And it's just not labeled with numbers. So, Pew Research Center asked a random sample of parents if they knew their child's cell phone password. Of the 1,060 surveyed, 551 said they did know the password. Does this sample result give you convincing evidence that more than half, greater than, of all parents know their child's password? Carry out a test at the 10%, 0.10 significance level. So let's do one real quick. One. That's usually, it's telling us 10 instead of 0.05. So, P is the proportion of parents that know their kid's password. Or their child's password or whatever. Okay? So again, we just make a very simple statement. P is a proportion of, and we just pretty much copy it from the word problem. And how many people were there? 1,060 parents surveyed. P hat, that's going to be our proportion. That's going to be the 551 over 1,060, which equals 0.52. That's P hat. And alpha was given to us, 0.10. Number two, we're going to check for large numbers and random. So we write random, and we're going to put question mark, and we're going to say given, check mark. Then we're going to check for large numbers. Wow, that was a big one. 1,060 times 0.52, which is our p hat. And that's going to give us 551. And we're going to do 1,060 times 0.48, 1 minus p hat, equals 509. That's going to give us our 1,060 people total. Both of these are greater than or equal to 10, by far, check mark. Now we're going to add one thing. This was on the last quiz. We said interval. We're just going to add this right here in the check part. One sample z-test. Last time it was one sample z-interval. I actually did not take off right with that one on the quiz, but it will be on the next one. One sample z-test. It's just a requirement to say that. Now, number 3. We do the ho and the ha. Ho, ha. So P is equal to, remember up in the problem they said more than half of the parents. So that's our benchmark. That's what we're looking at. So half the parents. And then since it said more than half, we're going to say P greater than 0.5. And my bad. Just draw an arrow. I just drew it in the wrong spot. This goes down here. I'm sorry.
Number 3.
Yeah, it goes in 3. I'm saying. I got a little excited. Woo! Sample t-test. Later on, we're going to learn about a sample t-test, but that's later. That's going to be fun. Oh, yeah. So, number 4. Wow. Don't do that. Number 4. We do our simple calculation. 0.52 minus 0.5 over the big old square root of 0.52 times 0.48 over 1,060. And when we do that, we get 1.3. So for number 5, number 5, when we draw our, that was horrible, that's a horrible one. And we do 1.3, well, 1.3 is going to be about there, just approximately. Greater than is going to be shaded this way. And we look it up on our chart. When we look up 1.3, we're going to get 1.9032. But the problem is we don't want to the left. So we're going to do 1 minus that and get 0.0968. Teeny tiny number.
So,
Yes.
if it's already to the right of it, I mean, yeah.
If we were doing one that said less than, we would use that number. But since we're asking, since ha was greater than, we have to do 1 minus.
Okay.
If ha was less than, just go with what's on the chart. Good question. So now we're going to compare 0.0968 and 0.10. It's close. It's close, and if we rounded it would be 0.10, but we don't round. We leave it 4 numbers, so it's less than, isn't it? So now we start writing our paragraph dissertation. Same startup. Since my p-value is less than the alpha, we reject the HO, or the null hypothesis. If you say that the null, the HO, I don't care. You can write that too. No, because we're not in middle school. Which means we have convincing evidence, same statement again, that the proportion, again, this comes right from our beginning, parents knowing their kid's password is over 50%. So in fact, I'm going to do you a kindness here. Okay, if you look at the book, what the problem is, I know what the problem is. Okay, I'm going to do number 13 with you. Good. You only have 1 for homework. Okay, so we're doing the same thing. In the book, you'll see it's the proportion of this kid's school who prefers name brand chips. Name brand chips. So for number 1, P is the proportion of students at his school who prefer name brand chips. Okay? I do want you to look at this later in the book. Not everybody has the book. But if you look in the book, okay, our N is going to be a smaller one than we've been doing so far. N is only 50. That's a 5. 50 kids. Okay? The P hat, well, they talked to 32 kids. So 32 kids out of 50. That's 64%. And the alpha, I can't remember if it's given in the problem. If it's not, it's 0.05. It may be given in the problem. There's number 1. Okay? Take the proportion. It's just that same old boring sentence. Get the N, P hat, and alpha. If alpha is not given, 0.05. Number 2, now remember, this doesn't match the directions in the book. Just do this format, 1 through 6. Number 2, is it random? Question mark? It sure is, given. it said the problem in the book, you'll see that was a random survey. So, boom, that's done. Then we just do our large numbers. And we're going to take 50 times our p hat of 0.64 and our 1 minus p hat, which is 0.36. And that's going to give me 32 and 18. And that's both greater than 10, so check. We're getting kind of small. We've had some pretty huge numbers recently. We're getting lower, 18, but 18 is still greater than 10. We're good to go. So for number 3, maybe. Number 3, we're going to take the ho and the ha. The ho is p equals 0.5, and the ha is, more than half the people want name brand chips, 0.5. And we're going to write this a one sample z-test. And we're going to write it in the correct spot this time. Again, this is just a template you will follow.
You want to try that every time?
Yep. That's template. Number 4, we're just going to do the math. Okay. So z equals p hat minus p divided by the square root of 0.5 times 0.5 divided by 50. That's a 5, not an 8. And that's going to give me 1.98. Which leads me right in number 5. When I do my sort of non-skewed standard deviation, I just real quickly put 1, 2, 3 in here. It doesn't have to be beautiful. 1.98 is going to be like right here, right before the 2. I don't know why I wrote 2. I didn't. Put it right there and just shade a little bit. That's good enough. We're going to go to our chart and look up 1.98, which will give us an area of 0.9761. But we're going to do 1 minus. And that leads us to 0.0239. Which leads us right into our last step of 6. We're going to compare the 0.0239 and our 0.5. And again, it's less than 0.5. We're comparing it to our p-value.
So we should have 6 steps on every single one.
Every one. And now we have our dissertation. Starts to go ahead and try it. Tell the truth. I'm going to say null hypothesis because I can't get the little O on here quickly. We have convincing evidence. Ooh, look at it fly. He's gonna be on online. At the school. Who prefer, yep, he's got it. Name brand chips. Yep. Is over 50%.